In this session, we'll discuss about the slope deflection method. So, slope deflection method is one of the displacement method. It is used to analyze indeterminate structure for beams as well as frames. So, scientist George A. Banney has introduced this method in 1914. More than 10 years, this method is used until the moment distribution method is introduced. So, in displacement method, we assume rotation and displacements as unknowns and then we solve them and then we'll calculate the forces and moments from them. Examples of displacement method are slope deflection method and moment distribution method. So in this method, kinematic indeterminacy will be less than static indeterminacy. Suppose for fixed beams, the static indeterminacy is 3 and the kinematic indeterminacy is 0. So coming to assumptions, the first assumption is all the joints in the frame are taken as rigid. The second assumption is in this method, axial forces and shear forces are neglected, only bending moment effects are considered. Coming to sign conventions, clockwise moments are taken as positive and anti-clockwise moments are taken as negative. Coming to rotations, moment produced due to rotations, clockwise rotations are taken as positive and anti-clockwise rotation is taken as negative. And then you can see this in the figure. So for settlements, when the displacement leads in clockwise rotation, the settlement is taken as positive. When it leads in anti-clockwise rotation, the displacement is taken as negative. Or we can say in another way that if right side support is below the left side support, we will take the settlement as positive and the vice versa. Coming to applications, this method is used for continuous beams and frames with sway and without sway. Coming to the derivation of slope deflection equation, so first we'll consider a continuous beam of span A, B, C, D which simply supports. From this we'll take a span AB of length L. Taking intermediate span AB, let AB be a member of a rigid structure with a point load. So after loading it deforms, and the deformation shape we can, so here we assume some settlement at B, and at A there due to the bending there is some rotation theta A, clockwise rotation, and there is delta settlement, and at B the slope, let the slope be theta B. So in the first step of derivation, we will convert the span AB as fixed beam and calculate the fixed end moments. So MFAB and MFBA. In the next step, we'll the rotation at A and B. We'll apply the rotations at A and B. Rotations at A, we will release the fixity at A point. Then you can see the figure there. We have released the fixity at A. And there is a clockwise rotation theta A. So here the moments at A and B are shown. So clockwise moment at A and clockwise moment at B. So at B there is a hogging. Here the formula theta A is ml by 4ei. From here m, that is ma, is 4ei by l theta A. So moment required to cause theta A 4ei by l theta A. So the reaction formed at opposite end will be 50%. 50%, that is 50% is carried over the fixed end, other end, that is mb equal to 2ei by l theta A. So next we'll apply the rotation at B. Now we will release the fixity at B points, and then you can see the figure there. At B we have applied a rotation, clockwise rotation theta B. So due to that a clockwise moment is formed MB, and at A as there is a sagging, so clockwise moment is there, so MB equal to 4ei by L theta B. Therefore half is carried to MA, therefore MA equal to MB by 2, that is 2ei by L theta B. Next we will consider the effect due to settlement. Let support B sinks by delta. So then this, so as the right side support is below the left side support, we will consider this delta as positive. So the formula for in this case is MB equal to 6ei delta by L square, MA equal to 6ei delta by L square. Since the rotation is clockwise moment, therefore the moment since the rotation is clockwise, moment will also be in anti-clockwise direction. Next, by using superposition theorem, the final end moments will be the summation of all the moments combined. Therefore, MAB equal to MFAB plus 4EIL by L theta A plus 2EI by L theta B minus 6EI delta by L square. Therefore, MAB equal to MFAB plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. So this is one of the slope deflection equation. The other slope deflection equation for BA is MBA equal to MFBA plus 2EI by L theta A plus 4EI by L theta B minus 6EI delta by L square. That is MFBA plus 2EI by L into theta A plus 2 theta B minus 3 delta by L. So these are these final slope deflection equations. So there ends the derivation for slope deflection equations. Thank you.